This first lesson is on the triangle sum conjecture. This is a geometry target from 8th grade, and I suspect you guys already know about this one. So I have two triangles. One is obtuse, the other one is acute. I might be able to say these are both scalene in that their side lengths are all different lengths, but the geometric notation is not there, so I can't say. But I do know that this is obtuse because I can place this angle into the corner and see that it's larger than 90. And I can place each of these angles into the corner and note that they're all less than 90 degrees. So definitely obtuse and acute. They might be scalene. They might be isosceles or equilateral, but I can't say because the hash marks are not on those sides. No geometric notation. So regarding the triangle sum conjecture, the sum of the angles in a triangle. So in the synchronous lesson today, we did a paragraph proof. We wrote an argument that basically said that if we take the three angles and we add them up, then we get 180 degrees. The proofs, there are three types: flowchart, paragraph, and two-column proof, are part of a different module. You won't be assessed on those in Unit 4, but you need to know the triangle sum conjecture because then that will help you answer questions on a test. If you combine or add those three angles, you get 180 degrees. It doesn't matter what type of triangle you have, whether it's obtuse, right, or acute, the sum of all the angles in a triangle add up to 180 degrees. Linear angles. Now notice I didn't say linear pair. I said linear angles. Angles that add up to a line or a straight angle. If you were to extend that pattern with a quadrilateral and a pentagon, quadrilateral is easier to see. If I can piece this back together. I can take the angles of a quadrilateral, tear them apart, combine them in a way that the vertices of each angle are shared. Notice the vertices of each of these angles are all meeting at that one point. I can prove that the sum of the angles of all quadrilaterals is 360 degrees. And then you see this pattern: 180 for a triangle, 360 for a quadrilateral, 540 for a pentagon, and 720 for a hexagon, and so on. Every time we add a side to a polygon, we are adding 180 degrees. Questions like this one, number 8, which is in the slides, can show up on a test. So it's important to note where the triangles are. If you were to count these up, go ahead and do that now. Most of you will come up with 6. That is because some students don't see these. These are the larger triangles. Now this second one, the second larger triangle, note that it has angles 71 degrees, 40 degrees, and then this one, A, is not yet known, but you use the triangle sum conjecture that says that 40 plus 71 plus A equals 180. You can quickly solve for A. And then seeing that B and 133 are a linear pair, you can solve for B. Once you know that information, you have A, you have B, you know this angle, that's a linear pair with C. You can find out what C is, and it's sequential. Some of you may notice that C is equivalent to A plus B because A plus B, the sum, is supplementary to this angle. C is also supplementary. So A plus B must equal C. Now let's talk about isosceles triangles and the isosceles triangle conjectures. Imagine you're given this task: to construct an isosceles triangle with base AB. It doesn't state what my other two sides must be. I just know that I have a base AB. I can choose any distance on my radius for my compass here, and I'm going to throw two arcs to one side of AB. And those two arcs are going to be equidistant from A and B. If you remember from copying a segment, that I can use the same technique to have two segments that are congruent to each other. Doing this will cause me to have two sides of this triangle to be congruent to each other. They're congruent, so I'll mark them as congruent using the geometric notation. We can call this C. AC, segment AC is congruent to segment BC. Now, let's talk about the parts here. The base is AB. The sides AC and AB are known as legs. These are the legs of an isosceles triangle. Legs, and the third side is the base. C is known as the vertex, or the vertex angle. Angles A and B, because they are on the base, these are base angles. So there's your notation, or your names for the different parts of my isosceles triangle. A base, the third side, there's not congruent to the legs. The legs are the two sides that are congruent. Vertex angle is the angle formed by the two legs. The base angles are the two angles formed by the base and one leg. Now, the conjectures. If I were to complete the perpendicular bisector of the base, then I would bisect the base. I would have a 90-degree angle at the base and the altitude, and I could fold this triangle over onto itself. I would cut it in half on the median. The median is the midpoint to the vertex on the opposite side. That would be a proof that these two angles are congruent. And there's a conjecture that states that if you have an isosceles triangle, the angles opposite the legs are congruent. You have other conjectures that say that if you have two sides of a triangle are congruent, then it is an isosceles triangle. You can also say that if you have two angles of a triangle that are congruent, you have an isosceles triangle. That is essentially all you need to know about isosceles triangles. The questions can show up with a little bit of algebra in them, and we'll take a look at those next. This question asks you, what is the measure of angle R, and what are the lengths of QR and SR? It gives you the information that the perimeter of triangle QRS is 53 centimeters. So you know that this one side, QS, is X. You know that this hash mark is the same as this hash mark here, so this must also be length x. The perimeter is 53, so the sum of x plus x plus x, which is 3x plus 5, equals 53. Solving for x gives you one of the legs, and you know it's congruent to the other leg. So that gives you QR and SR. Note that Q is 90 degrees. It's labeled as right, it's 90. So in the previous lesson, you know that Q plus R plus S, those three angles add up to 180, the triangle sum conjecture. So subtract 90 from 180, you're left with 90, so it must mean that S plus R equals 90. You know the base angles of an isosceles triangle are congruent, therefore each of these angles must be 45 degrees. Again, a lot of this is fairly intuitive, and I think much of it was taught in 8th grade geometry. Take a look at the slides and both lessons. They're under today's date, March 15th, asynchronous lesson for period 3. Take a look at the problems at the end of each set of slides. The next set of slides after those give you the solutions. Self-assess, please, and then check in on Zoom if you have any questions.